How are you doing? You ready to do the the review questions for Module 2 of Apologia Chemistry, 2nd edition? Let's go! Okay, so can you read number 1 to us?
Man pushes a stalled car for 2 minutes. During the first 1.5 minutes, the car does not move. But for the last 0.5 minutes, the man pushes even harder and succeeds in getting the car to move. Is the man working for the entire 2 minutes? If not, does he ever succeed in doing work? If so, when?
So it's important here to realize that we're not just talking about a common understanding of the word work. We're talking about the chemistry understanding of the word work. So the text defines work for us. Can you find it in the text and read it out loud? Thank you so much.
Work, the force applied to an object times the distance that the object travels parallel to that force.
Right, so if the object doesn't travel at all, the distance that it travels is 0. And so when we multiply anything by 0, the answer, of course, is 0. So the amount of work that the man is doing for the first 1.5 minutes is no work. He's doing 0 work. Okay, so how about the last 0.5 minutes?
Then he is working.
That's right, he is working. Blue Man, I hope you'll soon run out of helium so that you can talk in your normal voice again. Thanks. Okay, can you read number 2 to us?
Classify each of the following as having either potential or kinetic energy or both. A lump of coal. B, a flash of lightning.
Okay, well, let's do them one at a time. So the lump of coal, which kind of energy does it have? Kinetic or potential?
Potential energy.
That's right. Okay, so all the energy is stored energy. It can be burned and stuff. B?
A flash of lightning. That's kinetic energy.
Right, so the lightning flashes in motion. It has kinetic energy. Has it got any matter?
No.
No, so it couldn't even have potential energy, okay? How about letter C?
A candle flame.
Okay, candle flame. Similar in a way to the lightning flash in that it has no matter, right?
Kinetic energy.
Right. It has heat. How about letter D?
That has both. That's a tornado. It has potential and kinetic energy.
That's right. The air has potential energy and the air is moving with kinetic energy, so it has both. Okay, please read. So that's all for number 2, right?
Yes.
Good. Please read number 3 to us.
A chemist watches the temperature of a vat of liquid and notices that it decreases over time. What can the chemist conclude from this observation?
Okay, I'm going to interrupt for a moment. So we remember early in Module 2, we spoke of heat as being energy that we can measure by changes in temperature, right? So if the temperature is decreasing, there's a loss of heat, right? So since heat is energy, then what is our conclusion?
The vat of liquid is losing energy to the environment around it.
Right. If it's losing heat, it's losing energy, right? Because heat is a type of energy. Okay, number 4.
If a hot object is totally insulated from the outside world, will its temperature ever be able to change? No, it will not.
Right. So temperature changing is absorbing or giving energy to things around you. That's how temperature changes. This is a theoretical example. We can't actually create such a situation experimentally to test it, but it's kind of a definitional obviousness. Would you agree, Balloon Man?
Yes.
Okay. Let's look at number 5, and then we're going to start another video after this. Go ahead.
Why should you never look to science as an ultimate source of truth? This is because science is created by humanity, and as humanity is flawed, therefore science is flawed. However, since the balloons are not flawed, balloon science is infallible.
Yes,
Therefore,
well,
once we take over, you will have no worries about the nature of the existence.
right. Science is a way of understanding the world, right? Of making sense of our observations of the natural world. So it doesn't pretend to be an ultimate source of truth. It is a tool, as it were, for understanding the world. Okay, and thank you, Balloon Man, for your reassuring words.